this video, we are going to explain about the project title, which is Machine Learning and Deep Learning Approaches for Cybersecurity, a review. Internet is like a big highway with lots of traffic, but sometimes there are hackers who try to sneak in and steal the information. We need to address this issue because more and more of our lives are online, and we want to make sure that our information is safe and private. To make internet as a safer place, we are using technology to protect personal information like emails and social media accounts from malicious people who want to steal or misuse it. This initiative leverages intelligent computer programs to identify potential threats posed by digital hackers, much like deploying a digital security guard that recognizes and stops malicious individuals in their tracks. This initiative identifies and halts internet cyber attacks while ensuring the digital doors and windows, guarding personal information remains secure. This measure collectively aims to enhance internet safety and security for all the users. The main goal is to enhance internet security by leveraging a diverse set of machine learning and deep learning algorithms, including SVM, random forest, voting classifier, decision trees, k-nearest neighbor, naive-Bayes, linear discriminant analysis, and logistic regression. We utilize these algorithms as a specialized digital security guards, each equipped with unique abilities to detect and counter cyber attacks. Ensuring a robust defense against potential threats, the ultimate aim is to create a safer online environment where personal data is shielded from harm and misuse. And these algorithms, along with k-means, CNN and CNN with LSTM, and also autoencoders play a vital role in achieving this goal. Requirements of the project are hardware requirements, and in that, operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB above are needed. Coming to software requirements, Anaconda 3 and Visual Studio Community version is needed. In the flow of work, we have designed few modules to implement the project, and the first module is importing the packages. This module involves importing essential Python libraries like NumPy and Pandas for data manipulation, Seaborn and Matplotlib for visualization, scikit-learn for machine learning, and TensorFlow for deep learning. Exploring the dataset using IDS anomaly data. In this step, we explore the dataset related to intrusion detection system anomalies. This involves loading and examining the dataset to understand its structure, variables, and potential anomalies. Coming to data processing, Pandas data frame. This step involves using Pandas library to create a data frame, which is structured data format, to organize and pre-process the dataset. It includes tasks like data cleaning, transformation, and handling missing values. Keras data frame. Keras integrated with TensorFlow is utilized for deep learning tasks such as creating and pre-processing for neural network models. Visualization using Seaborn and Matplotlib. This module focuses on visualizing the dataset using Seaborn and Matplotlib. Here we create informative plots and graphs to gain insights into the data's distribution, patterns, and anomalies. Feature selection using PCA and RFE. Feature selection is performed in this step. Principal component analysis and recursive feature elimination techniques are used to identify, retain the most important features, and reduce dimensionality. Splitting dataset into train and testing. In this step, dataset is divided into two subsets, training and testing sets. The separation allows us to train machine learning and deep learning models in one proportion and evaluate their performance in another. Coming to building the model, multiple machine learning models and deep learning algorithms are employed in this step. The first model is SVM, which is support vector machine. This algorithm is used because it is effective in binary classification tasks. SVM tries to find the best separation hyperplane between different classes, making it valuable for identifying anomalies and threats in cybersecurity. Next one is random forest. It is an ensemble learning method known for its robustness and ability to handle complex datasets. It is used for its capability to capture intricate relationships within the data, making suitable for detecting anomalies. Voting classifier. It combines multiple machine learning algorithms to make predictions. It identifies to aggregate the strength of various models, potentially improving overall model accuracy and reliability. Decision trees. Decision trees are interpretable models used to make decisions based on input features. They are employed for their simplicity and ability to reveal decision-making process in cybersecurity. KNN, which is K nearest neighbor, It is used for simplicity and effectiveness in classifying data points based on their similarity to neighboring points. It can be useful for identifying patterns in cybersecurity data. It is used when dealing with cybersecurity data that includes categorical features. Coming to naive Bayes, it is a probabilistic approach. It is classification algorithm suited for text and categorical data. It is used when dealing with cybersecurity data including categorical features. Coming to LDA, which is linear discriminant analysis. It is used for dimensionality reduction and feature extraction. It can help improving the efficiency of model by reducing the number of features while preserving the information. Logistic regression. It is a straightforward binary classification algorithm. It is chosen when a simple yet interpretable model is required for cybersecurity tasks. K-means. It is a clustering is used for unsupervised learning, particularly for grouping similar data points together. It is applied for anomaly detection for data exploration. CNN, which is convolutional neural network. CNNs excel in image-based tasks due to their ability to detect hierarchical patterns. They are used when image data or visualizing elements are part of cybersecurity dataset. Coming to CNN with LSTM, this combination is suitable for sequential data analysis. It is used when the order of events or sequences in cybersecurity data matters. Autoencoders. Autoencoders are used for dimensionality reduction and feature learning. They are applied to extract relevant features and patterns from the dataset. Coming to training the model, in this phase, the selected algorithms and deep learning models are trained using the training dataset. The models learn patterns and relationships within the data. Flask framework with SQLite for sign up and sign in. Flask is utilized to create a web-based user interface for user registration, which is sign up, and login, which is sign in. SQLite is employed as a database to securely store user information. Coming to user gives input as feature values. Users provide input data representing features relevant to cybersecurity. These inputs are used for making predictions. Trained models is used for prediction. In this step, the trained model learning and deep learning models are utilized to make predictions based on users' input. The models used to detect anomalies or threats. Coming to the last module, which is final outcome, is displayed through front-end. In this step, the predicted outcomes such as cybersecurity threats, alerts, or insights are displayed to users through front end of the web interface created using Flask. Users can access the results and take necessary actions based on the predictions. Comparison graph of deep learning models. This is the comparison graph using deep learning models. Here on the x-axis we have the accuracy scores, and on the y-axis we have the algorithm names of deep learning models, and these are the accuracy values. This is the comparison graph of machine learning models. Here also we have on x-axis accuracy score and on the y-axis algorithm names. Among all the algorithms, voting classifier is performing well. For execution, we need to open the code folder which contains the source code files. This is a static folder. This consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains all the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is the model file. This file contains the algorithm information which will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and all outputs all in one place. It allows user to write and execute code in individual cells. This is sign-up file. This file is the database file used to store the user information. Now we need to copy the path of code folder from the address bar of the file explorer. So I will copy it. Now I will open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. and now we need to click on enter. So the current directory is changed to the code folders path. Now we need to type python space app.py. This command will compile app.py file using the command python space app.py. This command will execute the Python script and perform runtime check for syntax, errors or any logical issues. Now we need to click on the button enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, which is this one, and the port number, which is this one. Now we need to copy this local link and paste it in any browser. I prefer Google Chrome, so I will paste it in the Google Chrome. Here I need to paste the link and click on enter. This is the homepage of the project which is displayed in the browser, and this front end is built by using the Flask framework, and this is the homepage of the project. Now we need to click on sign up. And here we need to fill all these registration details if we are registering newly. As I have already registered, I will directly click on the button sign up. Now I need to enter my credentials, which are username and the password. Now I will click on sign up. So this has redirected to the home page. Now I need to fill all the parameters of cybersecurity and then click on submit. Based on that, we will have the predictions. Now we will enter step by step all these parameters. I have entered all these details of the parameters, and now I will click on submit. So based on the input provided, the ML predicted with the benign intrusion detection systems. Now we will try with the other details. Here now I will fill all these details. So I entered all the details, and now I will click on submit and see what will it predict. So based on the input provided, the ML predicted that with BOT intrusion detection systems. Now we will give the other input and see what will it predict. I gave all the necessary information and see what will it predict. So based on the input provided, the ML predicted with DOS attacks golden knife intrusion detection systems. Now we will give other input and see what will it predict. I entered all the inputs and click on submit. So based on the input provided, it is predicted that benign intrusion detected for the systems. In this way, we can give any input. Based on that, we will have the predictions, which are intrusion detection systems. Now we will log out. A multitude of machine learning and deep learning algorithms including SVM, random forest, voting classifier, decision trees, k-nearest neighbors, naive-based linear discriminant analysis and logistic regression are harnessed for adopting a multi-phase strategy in enhancing internet security. Although each algorithm possesses its distinct strengths, the voting classifier stands out as the consistent track record of delivering superior prediction accuracy compared to individual models. This collaborative intelligence significantly strengthens our capacity to detect and address cyber threats with efficiency and precision. In pursuit of overarching goal, these algorithmic endeavors plays a vital role in significantly fortifying the digital landscape, guaranteeing safeguarding of personal data, and elevating internet security for all the users.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.